detection-based approach for network security attack. This is the work that we have done at Akademi in this project. And so in a little bit about the introduction about anomaly-based intrusion detection. They are a bit different than the signature-based intrusion detection. So in signature, you have learned some sort of signature or the pattern of certain attack, and then whenever we find that pattern that in the traffic, we consider that traffic as attack. But in anomaly-based intrusion detection, the purpose of this that the intrusion detection has learned how the normal traffic looks like, and any deviation from that normal traffic is considered anomalous or malicious. So this way we can also discover or detect new type of attack, which is not possible with the signature-based attack. So this is the motivation that why anomaly-based intrusion detection might be a good idea in some cases than using the signature-based attack. And most of the intrusion detection system, they relies on network flows for doing the attack detection. And network flow is just the slide is not advancing.
It's on the other laptop, I think.
Oh. Right. Should I go?
No, because
I change here. It doesn't change here. Okay. Then I can do it here. Oh. Okay. Yes. So I begin or from the beginning? Should I start from the beginning? Or? It's okay. Okay. So so most of the intrusion detection system, they rely on grouping the packets into a network flow, and flow is just a sequence of packet where they share some common characteristics such as source and destination IP addresses and protocol types. And here in this figure, we have two consecutive flows, so flow 1 and flow 2, and they represent the communication between the network and some services running on the system. And traditionally, once we have all the packets in a flow, the intrusion detection system extracts some statistical based features such as total byte sent or received, or number of packets that sent or received in that flow, and then based on those features, they make a prediction. Which can be considered as a limitation, because if we are waiting for the whole flow to be completed, then if it was an attack flow, it means that the attack has been executed completely and it has caused the damage to the system. So it would be ideal that if we could detect an attack as early as possible and then stop it from completion. And this is the idea that we propose an early intrusion detection system, which with the objective of detecting anomalous traffic as early as possible. And the overall approach can be divided into two stages. On the first stage, we train a classifier where we require normal data, and we require some few anomalous traces to train the network. And once we have the model, then we can use it for monitoring and detection the anomalous traffic. Basically, the structure looks like this, that we have a network probe, which is sniffing the traffic between the system and the untrusted network and sending that traffic through the monitoring tool. And then monitoring tool is using the classifier which we have trained in the previous stage, and then basically producing the prediction based on the classifier and the network traffic. In this approach, for anomaly detection, we adopted this deep one class classifier. And the basic idea behind this concept is that we have, for example, we have this normal or actual representation of samples, for example, on the left side. So we can say that these circles are the normal traffic, and then these diamond shapes are the anomalous traffic in the original space. And then we trained a classifier, which is W theta, which transform this original space into a latent space where the normal sample are closer to a center C, which is predefined, and the anomalous samples are as far as we possible from the center. So this circle or this hypersphere would become our boundary, which we will use to identify whether a given sample is anomalous or not. So based on the radius from the center. And for example, here I have plotted some traffic from the data set, and here it's a bit in a reverse. So these red circles represent the normal traffic, and then these blue cross represent the anomalous traffic. And and this is how it looks in the original space. So we can see that it's quite mixed together. But after training the network, it is the same data that is projected in the latent space, and we can see that it has been separated. Although there are some overlaps, so we can still see some these red circles, and we can still see some crosses or the blue circles here. But overall, the separation is quite distinguishable or significant than if we compare it with the original space. We used relatively a very simple model, which is by design, because we would like to use this model in real-time monitoring. So we would like to have a like a lightweight model, so we can generate prediction quickly. It's basically a 1D convolution, leaky rule activation function, and then global average pooling, and then we have a dense layer to kind of provide us the representation in the latent space. We use the CIC-IDS 2017 dataset, where we have normal traffic, and then all the attack types are considered as anomalous. And we can see here also that if we compare the number of flows in the normal traffic and then in the anomalous traffic, there is a huge imbalance. But although we have a few sample as compared to anomalous sample as compared to normal sample, we were able to achieve quite good results. So this is where we can see this kernel density estimation plot of anomaly score that we assign to each sample in the test data set. And we can see here that this vertical line, this black vertical line, represents the threshold. And it's quite challenging in anomaly detection to have the ideal threshold which clearly separate the normal traffic and the anomalous traffic, because it's some of the samples overlaps. But and here we the way we calculate the threshold is the 99th percentile of the anomalous score on the normal sample from the training data set. So we don't calculate the threshold on the test data set. We just evaluate on the test data set. And in figures, we can see that we able to get 0.96 recall on normal traffic, 0.9 on anomalous, a relatively low false positive rate, and good PM score. And then we also evaluate how early the earliness of our approach, and any value which is close to 1. As the value get close to 1, it means that it's good and it can detect an attack with a few packets. And if it gets to 0, it means that it has to see all the packets in the flow to make a correct prediction. And here we can see that for the normal traffic, from 7 to, after just looking at 7 to 8 packets out of 124 packets, our model was able to predict the class of the flow. And in case of anomalous traffic, 1 packet was enough to out of 16 packets to detect to classify it as anomalous traffic. We also tested our approach on another data set, and this data set has a different type of traffic or from different applications. And we considered the traffic from on the left column, on the first column, as normal. So it has encrypted traffic from Gmail, Outlook, MySQL, BitTorrent, and then in the second column, this bots traffic is considered as anomalous. And here the imbalance is not as bad as from the previous data set. And then we used and this is the same, the kernel density estimation plot. And here we also follow the same approach. We calculate the threshold as the 99th percentile of the training data. And here we also see that the threshold, there is some overlap, but overall the threshold is quite good to separate the anomalous sample from the normal. And in figures, we were able to get quite good results. So, and we use the same model, so we don't change the model parameter also. So it's not, we didn't. So even though we have a large number of samples, we were able to get a good result with, using the same lightweight model. And we have good recall value, and then we have relatively low false positive rate. And then in terms of earliness, we could see here that by looking at just 1 to 2 packets out of 8 or 9 packets, we were able to correctly detect the class of a flow. So in conclusion, we propose an early anomaly intrusion detection approach. We evaluated on 2 data sets, and we were able to detect the anomalous traffic by looking at 1 to 2 packets. And in our future work, or the work I'm doing right now, is that if it's possible to just train on this anomaly detection with only normal samples. So in case you have no anomalous sample, that would it be able to get good results with that also. And I think that's it.